You ever build a machine learning model that just seems a little too good to be true? You see that amazing accuracy score, and you think, wow, I've absolutely crushed it. Well, today we're going to pull back the curtain on a silent model killer that turns that dream into a production nightmare.
And there it is, 95%. I mean, what a score, right? During development, this looks fantastic. You've tweaked your model, you've pre-processed your data, and the results are just stellar. You're probably thinking you're ready to deploy and, take a well-deserved victory lap.
But then you go live, you push it to production, and suddenly performance just hits a wall. That beautiful 95%, it plummets down to 60%. Your model is failing on new, unseen data, the business is totally confused, you're frustrated, and pretty much everyone is asking the exact same thing. What on earth happened? What is this massive gap between your test results and the actual real world? Come on, this isn't just a small drop, it's a catastrophic failure. Okay, let's really dive into this, because the answer is a subtle but an incredibly common mistake that hides in plain sight. The culprit has a name: data leakage. And it's one of the sneakiest problems in all of machine learning, because it doesn't throw any errors or warnings. Nope. It just quietly lies to you, promising this amazing performance that it can never, ever deliver. So what is it, really? Well, data leakage happens when your model accidentally learns from data it just shouldn't have access to during training. It basically gets a sneak peek at information that won't be around when it matters most, which inflates its performance in a completely fake way. The absolute best way to get this is with a simple analogy. Just imagine you're studying for a huge test. Data leakage is like your professor accidentally mixing in a few of the real final exam questions into your practice study guide. Of course you're going to ace the practice test. You've already seen the answers.
And this maps perfectly to machine learning. First, you get your training data. Those are your practice questions. Then, the leak happens when information from your test set, the real exam, contaminates that training data. And that leads directly to that crazy high accuracy, and then, inevitably, failure when the model faces the actual exam out in the wild.
Now, leakage can sneak in a few different ways. There's target leakage, which is when one of your features is basically a cheat sheet for the answer. Then you've got temporal leakage, a huge problem in time series data, where you accidentally use info from the future to predict the past. But for this explainer, we're going to zero in on the most common and subtle type, pre-processing leakage.
So here is the contamination point. The leak often happens with just one simple mistake in your workflow. If you take your entire data set and apply a scaler to it, which learns things like the mean and standard deviation, well, you've just let your training process peak at the test data. The fix, in theory, is just as simple. Split your data first. So how do we make that simple theory a bulletproof practice?
Okay, knowing the rule is one thing. But how do you enforce it every single time, without fail, especially when your projects get complicated? Well, you build a defense system. Let's talk about the solution, because this is how you make data leakage almost impossible.
This right here, this is the fundamental principle that needs to be burned into your brain. You split your data into training and testing sets before you do anything else. Any step that learns parameters from the data, like a scaler or an imputer, must be fit only on the training data. It should never, ever, ever see the test data during this learning stage.
Honestly, trying to manually keep track of this order of operations is just asking for trouble. So, the best practice, the professional way to build robust models, is to use a tool designed specifically to prevent this error, the pipeline object from scikit-learn.
And this is why pipelines are so dang powerful. You define all your steps in one sequential object. Then, when you call .fit, the pipeline is smart. It fits the scaler only on the training data, learning all the rules. Then, when you ask it to evaluate the test data, it just applies the transformations it already learned. No peeking, no relearning. It automates that cardinal rule perfectly.
All right, so what does this actually look like in practice? We've covered the theory, we've talked about the solution. Now let's see the hard numbers from the Titanic dataset example in our source material. This is where the lie is truly, truly exposed.
Whoa, just look at that difference. The leaky model, the one that scaled the data before splitting, is reporting a stunning 92.3% accuracy. Looks incredible, but the honest model, the one using a proper pipeline, gives us a realistic score of 81.5%. That is a huge drop, but it's the real score. It's the performance you can actually trust.
That's a nearly 11% accuracy boost that was completely fake. It was never real. This is the magnitude of the lie that data leakage tells you. I mean, can you imagine making business decisions based on a model you thought was over 10% better than it actually was? Yikes.
So let's wrap this up with your takeaway checklist. Number 1, always split first. Number 2, use a pipeline to enforce the correct order of operations and make your whole workflow robust. Be extra careful with time series data, no shuffling. And finally, if you ever see a huge gap between your test accuracy and your real-world results, the very first thing you should do is audit your entire process for data leak.
And that brings us to the final question you should really ask yourself after this. Go back and look at your projects. Look at your code. Is that amazing accuracy score that you're so proud of actually honest? Or is it hiding a leak?